So first up, let's just back it up here. So let's make sure that you know how to calculate slope between 2 points. Now, I know you know how to do it. Just for the record though, you will not be provided the formula for slope. You should know that one by now. So we're just doing some y2 minus y1 over x2 minus x1. Nothing crazy. Up to you if you want to label your points. You know I'm not picky about that at all. And let's just do it quick. So y2 minus y1, x2 minus x1. So of course on the top, -2, and the bottom, 3. So we are going to be calculating the slope through 2 points again today. So just be aware of that. We're also going to practice graphing some lines today because we're going to do that also.
Don't the negatives cancel out?
Negative.
Negative's on the top. Negative. Wait, never mind.
Okay.
I thought that was a negative.
Nope, no worries, Carter. I just want to make sure I was on the same wavelength. Okay, so this is a review from Friday too. If you remember, I know over the weekend it's easy to forget everything, we practiced plotting points and counting the slope from there. So that's all you have to do for the first line. I'm going to do it in blue. So I'm going to plot -1, 2. And then from that blue dot, we're going to count out your slope. Rise of 3, run 1. Now I'm going to put one more dot on just because we know I can't draw straight. Rise 3, run 1. Got it. Pretend I hit that point. All right, second one I'm going to do in red. So same idea, plot your point 2, 3. I'm going to give you a second to draw that second line. You count the slope. I have faith you can do it. Okay, what do you notice about the lines, Devin?
They're parallel.
They're parallel. Now I knew, hopefully you did too, before you even were going to mark those slopes out, and I'm going to draw the second line for you. I knew they were going to be parallel. Why? Same slopes, okay? So if I now count out my up 3, right 1, we can see they're going to be parallel. And you can remember, use the geometry, let's talk about geometry here, the geometry symbol, or, you know, right, parallel. So, recognize, remember, parallel lines have the same slope. We will be writing that down towards the end of our notes when we get into parallel and perpendicular. We'll talk about perpendicular too. All right, so we talked about this a little bit on Friday. You're going to see it a little bit more today. We are going to be using, in addition to point slope form, so many names, slope intercept form, which is our mx plus b. Now, you guys know this. The slope, of course, is m. We just practiced on that first warm-up problem, calculating slope. We're going to do that today. And, of course, your intercept is b. Now, one other thing to point out to you. Notice I have it written as a coordinate in ordered pair because your y-intercept is the point where the line touches the y-axis. We need it coordinate style. So don't just put like 5. You need to put the 0, 5. Make sure you're writing it as coordinates. That's an easy little detail to forget, okay? All right, so here we go. Determine the slope and y-intercept if possible, sketch the line. So first I want it in that y equals mx plus b style. So I'm going to solve for y. I'm going to get rid of this 2x, and I'm also going to get rid of the 9. So I've got my 3y. Now, order does matter for slope-intercept form. You have to make sure you have the x term first, and then the number. So you don't want to have it 9 minus 2x. You want x first. You guys know that. Divide by 3, we got. So -2/3 x, 9 over 3, 3. Now, it does want you to identify your slope and y-intercept. And your homework is so pretty. I typed it so nice. You'll see there's blanks for those. You can just fill them in. No such luck here. All right, slope, of course, the number in front of x. We got it. And we're going to remember that y-intercept of 3. We're going to write it coordinate style. 0, 3. We saw this on Friday too, but just a little quick review on how to graph it. Always do your y-intercept first. So I'm up here at 0, 3, and now, of course, rise over run. Down 2, right 3. Down 2. And if I had to guess, I haven't taught you anything new. And, of course, our line is falling to the right, which it should be for a negative slope. So questions on that guy? Too easy, I know. Okay, let's do this guy and move on, right? Now, only variable you have to solve for is x. So I guess I'm going to solve for x. So, of course, let's divide by 3. Now, this is a review from Friday. This is one of our special lines where you only have one variable in the equation. I'm going to give you 50-50. Is it horizontal or vertical? Vertical. So I'm just going to make a little note here, vertical. Now, I'm going to draw the graph first. Then we'll talk slope and y-intercept, of course. So I'm going to draw the graph. But here's the thing. I'm like, counting 7/3 sounds like a pain to me, okay? So I'm going to rewrite that mixed number style. 3 goes into 7 twice, and there's 1 left over. Okay, that seems easier to count. I'm going to go 2 full units, and I'm going to ballpark a third more. Okay, close enough, right? And then we said vertical. I'm going to try to draw myself a straight vertical line through there, but no promises. Now we still have to identify the slope and y-intercept. Well, what's 2 ways you can do the slope? What's the slope of all vertical lines? Undefined. Perfect. And if you're like, oh gosh, I can't remember. Remember, just pick any 2 points on this graph and count. Rise 2, run 0. 0 under the line's undefined. Okay, fun question. What's the y-intercept? Where does it hit the y-axis? None, it doesn't. We don't always have to have a y-intercept. So be on the lookout for some of those little special cases. Humor me, if it was y equals, what type of line?
Slope intercept.
If it was y equals negative 7/3, horizontal. Just for fun. Okay, so let's make ourselves a summary of all the different styles, forms of equations we're going to use. So I'm going to put the easy one on. We just reviewed slope-intercept form. Got it. We just did a vertical line that x equals negative 7/3. So those are always x equals a number, any number. We just reviewed, if I said if it was y equals just a number, horizontal. And then this bottom one is a review from Friday, a point slope form. That's your y minus y1. Okay. So one of the things we're going to have to do here in the upcoming problems is really a lot of them we're going to have to decide between the bottom 2. Now, clearly, they both have slope in them. So we're always finding the slope. Y2 minus y1 over x2 minus x1. How I determine which one to use, whether I have an intercept or a random point. If you have 0, 5, you have the intercept. I can use that, it's going to be easy. If I just have some rando point on the line, no 0, I'm going to have to go through like we did on Friday, point slope form. So it depends on what they give you. Let's see what we got. Write an equation line that passes the points. Use the slope intercept form if possible. The first thing before we even figure out what form we're going to use, let's get the slope going. So we just practiced this in the warm-up. You know how to do it. Y2 minus y1, our second x coordinate minus the first. So I'm going to have negative 7 over negative 8. And let's make those two negatives a positive. And again, don't forget, you will see one of the differences from Algebra 2. You probably have a few more fractions in here than you maybe did in Algebra 2. Now, next decision is, which form am I using here? Look at the points. Do you have the intercept or not? That's what's going to decide. So I'm looking at the points. Are either of these the y-intercept? No, boo. Okay, so I'm going to use point slope form. You can pick either point. We'll get the same final answer. I'm just going to be lame and use the first one. Okay, so I'm going to do y minus the y coordinate equals the slope, x minus the x. Now, directions wants it in slope intercept form, so okay, I'm going to distribute and do all the things. So 7/8 times x. Here we go, fraction masters. We don't need a calculator, right? What's 7/8 times 4? 7 over 2. All right, let's add the 3. I hear the calculators going, which makes me giggle. All right, we can do it without a calculator. I'm going to rewrite 3 in terms of halves. How many halves is equivalent to 3? 6, I heard it. 6 over 2 is 3. So negative 7 plus 6 -1 over 2. Now, if I asked you for the old y-intercept, you could tell it to me. What's the y-intercept? 0, -1/2. Yep, now we got it. It's a little fraction, no big deal. Any questions about that? Okay, next thing, I've already kind of showed it to you once last week, but we're gonna start using it more and more throughout the year. So I wanna make sure we are good about adjusting our windows and stuff on our calculators here in a minute. So make sure, I heard some of you getting your calculators out, make sure you get your calculator out for the next problem, because we definitely need it. Now, same thing, slope is gonna be fun with the -2/3, but we can do it. So y2 minus 1, x2, and that's x1. Now clearly the bottom is the easy part. Let's fill that in, right? Okay, 1. So I'm going to think about 1 as a common denominator. 3/3 really is the same as 1, right? -2/3 minus 3/3. Again, you can use your calculator, but we should really do some of this by hand. Now, because the top's a fraction, I'm thinking about this as a fraction. When you divide two fractions by hand, you multiply by the what? Reciprocal. And this is actually going to turn out kind of nice, I think. Because when I flip that 5 over 1 to 1 over 5, 5's cancel. So -1/3. Not awful for a slope. Again, you can use your calculator. You know I like to do the fractions. Okay, look at your points. Are either of these points a y-intercept? No, me and I mean you guys today. So obviously, let's probably use the first one because you're probably a little fractioned out if I had to guess. So I'm going to do y minus the y coordinate equals our slope, x minus your x coordinate. Now, same steal, distribute, combine the like terms. You guys know how to put it in the slope-intercept form. So -1/3, -1/3 times -1. That's not so bad. Okay, we can add 1. We don't need a calculator. 1/3 plus 1 more, 1 and 1/3. Or I guess if you did it in your calculator, that would be the same as 4/3. I'm very glad we don't have to graph these with the fractions and the y-intercepts. Got it. All right, any questions on that? Okay, calculator time. Now, like I said, I've kind of showed you this already, but it's something that's going to keep coming up, so I just want you to be good with your calculators. So I've got some screenshots on here, nothing exciting for us. We talked about the window button. Our standard window is the 10 by 10. We're going to change some windows here in a minute. And remember, to get it back to, because we're going to change the window, to get it back to your standard window, you're going to hit zoom 6. Okay, so take a look at it, use your calculator, graph it. We're going to look at those different viewing windows. So just like normal, go to your y equals and just type that guy in. Of course, it's in slope-intercept form, slope -8, y-intercept 5, no big deal. Just because my calculator is covering up the numbers, I'm going to grab this. I'm just going to, for right now, hit graph. Let's just take a little look-a-loo here. Okay, that's, yeah, down 8, right 1, yeah, looks good. Okay, so I'm going to go into window now, and I'm going to change it to what it has under the first window. So it wants the x-min at -5, okay, and you can just type -5, type over it, hit enter. 5 for the max. X scale, that means it's counting by ones, that's the same, okay. Y-min -10, Y-min, okay. We don't have to worry about the bottom two ever. Let's hit graph. Okay, so just so we can put it in front of us, bless you, I'm just going to steal that over here. Now let's put in that second window. So looking at the second window. So x-min -5, so that's okay. I'm just going to hit enter and get to the next one. And once the max at 10, got it. X scale still 1, whew, -80. Yikes. Seems like a lot to me, but okay, 80. And then the Y scale, it's going to count by 20s. All right, let's hit graph. Okay. So I'm going to steal the picture here so we can talk about these. So let me put the pictures up so you get them side by side. Do those look like the same line? So your window can really distort your picture a lot, okay? So when I look at this, I was like, oh man, especially that right one, that really seems like it skewed the slope to me. Because a -8, a down 8, right 1 should be pretty steep. This is a lot more slanted. So when it says describe the differences, I'm not gonna get carried away here and write a paragraph. I'm just gonna say that it distorted the slope. And I'm just gonna say that it looks more slanted. Should be steeper looking than that. And again, you're gonna see we're just gonna practice. This is really just to practice your calculator skills because we're gonna have some graphs coming up in the next few chapters. On a 10 by 10 window, you can't even see the picture on it. You have to change the window in order to be able to see the graph. Now, before we go to the next problem, I clearly have messed up your window now in your calculator. So before we do any more graphing today, I'm gonna hit a quick zoom 6 and put it back on our standard 10 by 10 window. So if your window ever looks different, just hit zoom 6 and that will get it right back to the 10 by 10. Just to practice our graphing calculator skills. Okay. Now, this is not on your sheet. This is straight off my Algebra 1 materials, everybody. You know parallel lines have the same slope. We know perpendicular lines meet in right angles from geometry. You know I love to reference geometry. And of course, the reason why the slopes, it says, of course, negative reciprocals. So let's clarify that and fill all this out here quickly. So of course, parallel lines have the exact same slopes. So two lines are parallel if and only if their slopes are, I should put the same. And then perpendicular slopes are opposite in sign. So you need one positive, one negative, and reciprocals. So 2/3, 3/2. You're going to be able to flip the fraction. So both of those have to be working in order to be perpendicular. So that's the last thing, this isn't new, but this is the last thing we're going to go over in terms of slopes. So determine whether lines are parallel or perpendicular. So it's all about the slopes. I'm going to do this guy in green. So I'm going to do the slope of the first line. So I'm just using y2 minus y1 over x2 minus x1. I feel like a broken record. y2 minus y1 over x2 minus x1. There are a lot of pluses, so I got 6 over 3. Little mental math. Got it. Now, I'm going to do the slope of the second line. I'm going to do that one in purple. So same thing. y2 minus y1 over x2 minus x1. So I've got -8 over 4. Got it. Okay. Questions for you. Are the slopes the exact same? So they're not parallel. Are they opposite in sign and reciprocals? No, they're opposite in sign, but we need a 1/2 in there. So we got neither, which does happen. Good. Any questions on calculating those slopes? Okay, last thing, combo lesson, combo example. We're going to use our y minus y1 equals m times x minus x1, our point slope form, and we're going to incorporate parallel and perpendicular into it. Okay, we can do it. So write the slope intercept form, the equation to the line, given a point. We have to make one parallel and one perpendicular. So 2 for the price of 1, kids. You have to have double the work here because we have to do parallel and perpendicular. Well, it's all about the slopes. So the first thing I want to know is what is the slope of the given line? So I'm going to solve it for y. So I know you can look at that and you know what the slope is. I'm just going to write it down for dramatic emphasis. Okay. So now I'm ready for part A in green, the parallel. So I'm just going to look at the slope of the line. To make one parallel to that, I'm going to use the exact same slope. So I'm just stealing it. And it wants it to go through that point. So there's my info I need. I'm ready to go. Now, once again, some of you guys say -3, 2, not the y-intercept. If it was, boy, we'd be done in the blink of an eye. Random point on the line. So I'm going to use point slope form. 1 minus the y coordinate equals the slope, x minus the x. Now, I am going to distribute and clean that up in a minute, okay? But I'm going to set up B, the perpendicular. So I'm looking at the red, the original line, the red. To make it perpendicular, I need opposite sign and reciprocal. What are you going to use for a slope?
1.
1. because opposite, of course, positive. Reciprocal of 1 over 1. 1 over 1. So really, I'm rewriting this green line because we still have to go through that given same point. I'm rewriting this bottom green line, but I'm going to swap out the slope to a 1. There's a 1 slope. So I'm just going to go through and simplify and solve these for y. Probably you've already done it, and clean them up. So let's distribute -1 through. And then, of course, I'm going to add the 2. So negative x, I can't write top, negative x minus 1. Now, here's one little tip for you. Let's say you're on a quiz or a test. You're like, oh gosh, I don't know if I used the right slope. Did I switch a sign? Did I not? Or I don't know. Graph that original red one and your green one and make sure they run horizontal on your calculator. It's a quick, easy way to check with a graph. All right, let's do this one. Well, 1 times x plus 3, I got that. And then let's add the 2. Now, same thing. If you're worried you missed a sign or you did something wrong, graph the original red equation and the blue one, and you'll see they meet 90-degree angles on your calculator. Quick, easy way to check it if you're ever worried, okay? Last one we're going to do. And I don't know why sometimes this gets people when I only put one variable in. Okay? So let's solve it. I'm going to add the 2. That's really my only play. We have seen that. What special type of line is just y and a number? Horizontal. So I'm just going to put you don't have to write this on your homework, but I'm just going to put it down in our notes. Okay. So same thing. We need a parallel one and a perpendicular one. I'm going to do parallel first. Now, these are almost easier because I really can do it with no work. If you have a horizontal line, what type of line is also going to be parallel to it? Another what? Horizontal. So I need another horizontal line. So I know it's going to be a y equals. Okay. Now, and I'm going to finish it, I am. P is the perpendicular. Remember, our red given line is horizontal. What type of line would be perpendicular to that? Vertical. So I need a vertical. And I know vertical lines are x equals. Now, let's not overstress here. We have to go through this point. So for our horizontal, y better equal, it's going to hit at -1. For the vertical, x better equal 3. So the horizontal and vertical ones are even easier because you don't have to do any work. But you have to keep it straight in your mind whether you're using x equals or y equals. Any questions about that? All right, that is as exciting as it gets today.